G'day chemistry students. In this video, what we're going to be looking at are reactions that involve acids and bases. This video will be covering dot points 6.1, point 3, and 4. Let's get into it. The first reaction which I want to look at is neutralization, simply when you put an acid and a base together. So we might already have somewhat of an idea of what this reaction is from years 9 and 10. When we put an acid and a base together, we know that they neutralize. This idea of, oh, well, the pH becomes neutral. It's no longer acidic. It's no longer basic. This isn't completely true. It's not a fair indicator of exactly what's happening in neutralization. In future topics throughout the remainder of the module, we will be unpacking neutralization in considerably more detail. But for the moment, what I want to focus on is that if we put an acid and a base together, it will form salt and water. And generally, the salt that is produced is edging towards being more neutral. So generally, when we're looking at a reaction like this, acid plus base leads to the formation of salt and water. That works really well when the base is an oxide or a hydroxide. So when a hydroxide or an oxide is the base in this reaction, the general reaction equation holds really well. If we go back really quickly to our common acids and bases, that works for these guys up here, excluding the carbonates. I'll come back to them in a minute. So works for hydroxides, works for oxides. Doesn't work so well for these guys though. And here we have an example like that. Neutralization reaction involving ammonia doesn't form salt and water. It just forms a salt known as ammonium chloride. When we start involving carbonates, a particular type of base in our acid-base reactions, we end up with a bit of a different general reaction equation here. It's an acid-carbonate reaction. So when we have a base that is a carbonate, we still form salt and water, but the carbonate component also lets off or releases carbon dioxide gas as a result. Really easy to see and observe. You definitely would have seen this reaction previously, at the very least when making a model volcano or something like that. The final reaction that we're going to be looking at today are acid-metal reactions. If you have an acid, put a metal in it, it can form a salt and hydrogen gas. Now, depending on the reactivity of the metal, something that we looked at all the way back in Module 3, the degree of reaction, the rate of reaction, the amount of gas produced will be different. That can also be determined by the concentration of the acid, a reaction rate concept that we looked at again in Module 3 as well. However, a salt will be produced, hydrogen gas will be produced. We've seen that happen with magnesium. There's some really concentrated acid in this container here, some concentrated hydrochloric acid making aluminium react really quickly. You will find that bases such as sodium hydroxide may be able to have like a base metal reaction that produces a salt and hydrogen gas as well. But these reactions can be sort of few and far between. It depends on the metal that's reacting. Generally speaking, when we're looking at reactions with metals, we're looking at that acid metal reaction. Thank you very much, everyone. In the next video, what we're going to be looking at in a little bit more detail are acid-base indicators. But until then, have a good one.